Hi, in this video we're going to be talking about circumference and arc length. Now, a quick note about notation. If you have a minor arc, it is an arc that is less than 180 degrees. So like KA right here is a minor arc because it doesn't go all the way around the circle. We could also say WA. A major arc is one that is greater than 180 degrees. So like this guy right here, that goes more than halfway around the circle, that is a major arc. And then finally, we have the kind of most common arc that we end up talking about is a semicircle. A semicircle is exactly 180 degrees. So minor is bigger. I'm sorry, major is bigger, minor is less. Semicircle is when we're exactly 180 degrees. So if we're looking down here on this one, if we're looking for major arcs, we're looking for arcs that are going to be more than 180 degrees. So let's see, I could do A to D. That would be pretty good. But to make sure that people know I'm talking about the major arc here and not the minor arc right here, I need to make sure that I'm using 3 points in the notation for that major arc. So if I'm going to do this one as my major arc, maybe I want to call it A. I can use either one of these. D. So A, F, D. So A, F, D is my major arc. But if I've got a minor arc, AD will work just fine. I could include B if I wanted. When you draw those arcs, make sure you draw a little like kind of arcy guy above it. So we're not talking about segment. We're talking about an arc. For this next one, let's play over here. So if I talked about the minor arc between F and E, that would just be FE. But if I wanted to go the long way around from E to F, I would need to include either A, B, or D so that people know I'm going the long way around. So maybe FAE to get the major arc instead of the minor arc. If we wanted to get a semicircle, we need to make sure that we're working with a diameter. So that would be FB. Which must have 3 points. So just like a major arc would, I need 3 points here. So FAB. So that people know I'm talking about this top part. If I didn't include that A, people might be thinking I'm talking about that bottom part. If I wanted to do a different one, maybe I want to do this chunk here. I want to include either B or D so people know I'm talking about this side and not that side. So A, D, E. How about that? Quick reminders about angles. If we have an acute central angle, an acute angle is like a nice little small guy. You need 3 letters for an angle, A, C, B. If we wanted to do an obtuse central angle, maybe I want to do FCA. Make sure that that central angle includes the center as the center point. Now, adjacent arcs are talking about arcs that are right next to each other. So like AB and BD. If I wanted to do these 2 pairs, I could do AB. It is a minor arc, so I only need 2 letters. And then maybe if I wanted to do BE, again, that's a minor arc because it's less than 180 degrees. So BE. All right, so finding the circumference of a circle is a very simple formula. The circumference equals 2 pi times r. There's another formula too where the circumference is pi times d because 2r is the same as the diameter. So if I'm looking at this one, 16 is our radius. So the circumference of this circle is going to be 2 pi times our radius, which is 16. So that's 16. So the circumference is 2 times 16, which is 32 pi. And this one said, leave your answers in terms of pi. So once I get that, I'm done. I don't have to do anything else. If I do this one, 3.9 is again our radius. So the circumference here is going to be 2 times pi times 3.9. 3.9 times 2 is 7.8. times pi, and I'm finished. It's that fast. The 16 is a diameter. If I wanted to find the radius, it's going to be half of the diameter. So our radius is going to be 8. But we get the same answer if we're using the diameter or the radius. We just need to make sure we're using the appropriate formula. If I use the diameter that I was given, circumference is just going to be pi times 16, which is just 16 pi. Done. If I use the radius instead, it would be 2 times pi times our radius, which is 8. 2 times 8 is 16 again. So we get the same answer if we're using our 2 pi r or our pi d formula. We get the same answer either way. Another little bit of review, if I'm looking for the measure of an arc in this circle, the arc measure is always equal to the measure of our central angle. Central angle and the arc always match up. So if I want AE, so this arc right here, it's going to be equal to its central angle. Since this is a right angle, this must also be a right angle. So AE has got to be 90 degrees. If I'm doing this one, the measure of DBA, so I want DBA, so I want all of this stuff. I know it is the major arc because I've got 3 letters, not the minor arc over here. So that's 130 degrees plus this 90 degrees to get this arc. Adding those two central angles together. So the measure of DBA has got to be 220 degrees. Last one, if I'm looking for AED, so this minor arc right here, they gave me 3 letters. They didn't have to give me 3 letters, but it was nice that they did. I need to know what the measure of that arc central angle is in order to figure out what this arc out here is. Or what I could also do is I know there's 360 degrees in the circle. So the measure of AED has got to be 360 degrees minus the measure of this major arc that's paired with this minor arc, the measure of DBA. Well, DBA ended up being 220 degrees in that last problem. So measure of AED has got to be 360 minus 220, so it's got to be 140 degrees. Now, unlike the measure of an arc, the arc length is asking about the length of this curve, not how many degrees it is, but the length of that in like inches or centimeters or whatever it might be. We use this formula. The length of a given arc is whatever its central angle is divided by 360 times 2 pi times our radius. That is going to give us the length of something like this. Ooh, this one's the major one. So how long all of that is going to be whatever our angle is times 2 pi times r. So let's plug those in. So it is whatever this angle is. So that whole angle is 360 degrees minus our central angle, which is 40. So that's going to be 320 degrees. So 320 degrees. Then we fill in the rest of the formula that we were just given. We get 360. It's always going to be 360 right there, times our 2 pi, times whatever our radius is. And in this problem, our radius was 9. So we're just going to type in 9 right there. And that's just a matter of like typing into our calculator. I can do a little bit of simplifying if I really wanted to. 320 divided by 360. I can divide both of these numbers by 40. 320 divided by 40 is going to be 8. And 360 divided by 40 is going to be 9. So times 2 pi times 9. Now, both of these are on the top of a fraction, so I got to multiply all these numbers together. 8 times 2 is 16. So that's 16 pi times 9 over 9 times 1, that's 9. But hey, 9 divided by 9, that's just 1. So those two cancel each other out. So we're left with our answer of just 16 pi centimeters. Almost forgot my units. Note that I'm just trying to find this length, so I would just write it as centimeters, not centimeters squared. In this example, I'm looking for the measure of all of these arcs. This one, and this one. But what I'm going to do is I've got a sneaky idea. I'm going to find the circumference, and then I'm going to cut that circumference into 4 equal parts because I've got 2 diameters here, and all of these should be the same. So this arc and this arc are going to be the same, and they will be half of a half from this arc right here. So I just need the circumference of this circle. So the circumference, I've got my diameter, so that is just going to be pi times my diameter, which is 24. So each one of these little segments is going to be that 24 pi divided by 4. So AB has got to be 6 pi. And same thing with this one. This has also got to be 6 pi. And then this one down here has got to be half of that. So that is 24 pi divided by 2, which equals 12 pi. Sneaky. This one again, I could use this formula up here, but I've got another sneaky idea, is if I find my whole circumference again, so circumference, this time I've got a radius, is going to be 2 pi times my radius, which is 3, so that's 6 pi. What I could do is if I cut this thing in half, and then in half again, then I know that this is going to be a quarter of my circumference. And then this area down here, this is half of my circumference. And then if I take these two, this is going to be like an eighth of the circumference, and then another eighth of my circumference. So let's try that out bit by bit. At this point, it might be simpler to just use this formula up top, but I'm feeling sneaky. So my arc right here for FG has got to be 6 pi divided by 4. So that is 3 pi over 2. That's no problem. If I go after this one, GH, GH has got to be 6 pi divided by 8. Okay, so divide both of those by 2. We get 3 pi over 4. Okay, cool. Last little bit, I've got this one. So this one, let's see. We need another point out here so we can get that major arc. We'll call that S for sneaky. FSH. So that's got to be half of my circumference from this chunk right here. So that's 6 pi over 2 plus an eighth of my circumference from right there. Oh, 6 pi. So that is 3 pi over 1 plus 3 pi over 4, if I'm dividing top and bottom by 2. I need a common denominator there so I can put those two together. So that's 12 pi, which I probably should have done first before I simplified. So 12 pi over 4 plus 3 pi over 4, we get 15 pi over 4. Huzzah for our final arc. So in this one, probably don't go after this. I think I was a little bit too sneaky. You want to just use this formula. Figure out your angle measure, divide it by 360, multiply it by 2 pi r. Remember your notation stuff. It is if it is a major arc, a big arc that is more than 180 degrees, give it 3 letters. If it is a minor arc, you only need 2, but you can have 3 points in your notation if you like. With circumference, you need 2 pi r or pi times the diameter. So be careful if you've got a radius or a diameter. Thanks for watching. Bye bye.